Here we have a word problem. A number is 12 less than its square. What is the number? The key to these type of word problems is to take them piece by piece. The very first thing says a number, so we need some variable. X should work fine. Is a good indication of an equal sign. We have a 12, and then we have less than, so we're going to be subtracting 12 from its square, so we need to square the number. And now we can solve. When dealing with a quadratic, we want to get everything on one side. So I have 0 is x squared minus x minus 12. We can then factor two numbers that multiply to be negative 12 and add to be negative 1. That can be done by negative 4 and 3. Now I have x minus 4 is 0. Adding 4 to both sides gives me x equal to 4. I also have x plus 3 equal to 0. And subtracting 3 from both sides gives me x equal to negative 3. For this one, the product of two consecutive numbers is 71 more than their sum. So once again, let's take it piece by piece. The product tells us we're going to be multiplying something. Two consecutive numbers means I'm going to be multiplying x by the next number, x plus 1. Is means equals. We have 71. More than means add. And then their sum. So we're going to add our two consecutive numbers. Multiplying the left gives me x squared plus x. Combining the right, I have two x's. And then I have 71 plus 1 to give me 72. I can subtract 2x from both sides. That gives me x squared minus x is equal to 72. Subtracting 72 from both sides gives me x squared minus x minus 72 equal to 0. We now need to factor this. I need numbers that multiply to be 72 and add to be 0. And we can do that with 9 and 8. Particular negative 9 and positive 8. Sorry, they add to be negative 1. So x minus 9 equal to 0 gives me x equal to 9. And x plus 8 equal to 0 gives me x equal to negative 8. Therefore, my consecutive integers would be 9 and 10, or negative 8 and negative 7. Here we have a rectangle. We know the length of the rectangle is 9 centimeters more than the width, and the area is 70 centimeters squared. We want to find the dimensions of this rectangle. So we have the rectangle. We don't know the width, we'll call it W. And the length is 9 more than. More than means add. So W plus 9. We also know that their area is 70. So 70 is what happens when we multiply length times width. So W squared plus 9W once we distribute. Since this is quadratic, we subtract the 70 from both sides. I now have W squared plus 9W minus 70. Now I need two numbers that multiply to be negative 70 and add to be 9. We can get this with 5 and 14. In particular, W minus 5 and W plus 14. When I set these equal to 0 and solve, I get W equal to 5. The other one gives me W equal to negative 14. Since we're talking about the sides of a rectangle, that number doesn't make sense, and the width is 5. This means the length needs to be 9 more than this, so 14. This one is very similar to our last one. This time we have a rectangular garden, and it's 3 times as long as it is wide. So this time we're going to be multiplying. Once again, we'll let W be the width, and then this will be 3W. The area is 972, which we get by multiplying our length and our width. So we have 972 is equal to 3w squared. I can divide both sides by 3. When I do that, we get 324 equal to w squared. And then we can then take the square root as long as we remember to do the positive and negative square root. The square root of 324 is 18, so I have 18 or negative 18, but the negative 18 doesn't make sense since we're talking about width. My length is then 3 times the width, so 3 times 18, which is 54. For this one, we have 2 cars leave an intersection. One travels north, the other travels east. When the car traveling north had gone 12 miles, the distance between the cars was 4 miles more than the distance traveled by the car heading east. And we want to know how far that eastbound car had actually traveled. This seems like a lot of information, and it's taken almost my whole slide here to actually write the problem out. So maybe there's a better way to get this organized so we know a little bit what to do. Maybe drawing a picture. We have them leave an intersection. One goes north, the other east. The one going north had gone 12 miles. We also talk about the distance between them, which is the straight line between them. And we know that this is 4 miles more than the car traveling east. We'll call that distance x. Now we have this triangle. We know this is a right triangle, which means it satisfies Pythagorean's theorem. A squared plus b squared equal to c squared. So we have 12 squared plus x squared is equal to 4 plus x squared. On the left, I have 144 plus x squared. On the right, we need to multiply this out, and we can use the shortcut, which says square the first number plus multiply the 2. 4 times x is 4 times 2, 8x, plus square the last one. We need things together, so let's subtract the x squared from both sides, and we can realize that it actually canceled on both sides, which makes this equation a little bit easier. I can then subtract 16 from both sides and get 128 equal to 8x. When I divide by 8, I then get that x is equal to 16. So the eastbound car had traveled 16 miles. For our last problem, we have an object that is thrown upwards with an initial velocity of 64 feet per second. We also know its height after t seconds is given by the formula 64t minus 16t squared. We want to know when it hits the ground. The first thing this problem gives you is the initial velocity. And to be honest, this is just extra information. It's completely unnecessary. All we really care about is its height. The ground is a height of 0, so when is the height equal to 0? So 0 equal to 64t minus 16t squared. We can factor and pull out a 16t. That leaves me with 4 minus t. I now have two equations. 16t equal to 0. Dividing by 16 gives me t equal to 0. That's when we started. So we probably don't want that one. The other one, 4 minus t is equal to 0. And if I add t to both sides, I get 4 equal to t. So this hits the ground after 4 seconds.